Good morning, class. Come on in. We got a lot prepared for you today. So let's go ahead, and I got your warm-up on the board. So I'll give you a few seconds. I just want you to go ahead and plot these points and go ahead and solve for the equation in standard form. So I'll give you a few seconds to work on that. Alright, so who can tell me where I need to start? We already got our graph written out here. We got it labeled. We have the x-axis here going horizontally, and vertically we have the y-axis. Who can tell me with these paired points which is the x-coordinate and which is the y-coordinate? Very good. X always comes first, and we have y. Just like in the alphabet, it goes x, y, z, right? So we have x first and then y. Okay? So let's go ahead and plot our points. So we got a 1 and a 3, so we're going to go over 1 on the x-axis, and then 3 up on the y-axis. And then we've got a 4 on the x, 4 on the y. Come up here, and let's just draw a line, because that's what we want to find, right? We want to find the equation of the line. So, what is our formula to find the slope of a line? Because we need that to find the standard form of the line, right? So, does anyone remember this? We have y2 minus y1 over x2 minus x1. That's how we're going to find our slope. You can also remember it's rise over run. So we put some arrows for rise over run. Alright, and we always work left to right. So this equation right here is going to be our first equation. It's going to be our second equation. So we got 1, 3. Let's go ahead and label it over here on the graph. 4, 4. Alright, so y2 is just going to be right here. So we got 4 minus our y1, which is 3, over x2, which is going to be another 4, and our x1, which is going to be a minus 1. So 4 minus 3 is 1. 4 minus 1 is 3. So we got 1/3. Now that's just our slope. And let's go ahead and look at this rise over run. So we've got how many? We've got 1, 2, 3 is our run. Very good. You can see that right there. And then our rise is just 1, which you can see right there. So both work, but this is more mathematically correct. And when we get into harder problems, it'd be better just to use the formula, just so that we make sure that we have it. And we can always check it. That's why I like math, because there's always more ways to solve a problem, so you can go back and check it different ways. Alright, so now, where is this line going across? It's going to go through about right there. You can keep this going backwards. Now, let's just use some logic on this one, alright? So, for every 3 movements to the left, the line goes down 1, right? So if we keep along the same pattern, we go 3 more, 1, 2, 3, then we're going to go down 1, right? So we're going to be at -2 and 2. Alright, so if that's the case, that means for every movement to the left or the right, we're either going up 1/3 or down 1/3. So if that's the case, right here we're at 3, right? So we're at that 1/3. So if we just have one movement to the y-axis, that means we're going down how much? Very good. We're going down 1/3. So what's 3 minus 1/3? Yeah, just 2 2/3. So what's our final formula? Well, you gotta start off with y equals, what's our slope? 1/3. And we're multiplying that by what? Yeah, we're multiplying it by x. So 1/3 x plus our y-intercept, which is 2 2/3. Very good. Now, what we've been learning about is slope, but also proportions. And proportions and slopes, we can use those in the real world for a lot of different things. We can do it for fitness tests, We can do it for prices and how they're going up, gas prices, all sorts of things like that. But one thing that we can really use them for is for population growth. So have y'all ever seen a slope that kind of does something and just goes up like that? Okay, that's an increase in slope. And just like that, and population usually is increasing, our world population is increasing. So most states' populations are increasing. So what we're gonna do today, and go ahead, I'm gonna let y'all use your phone to stay in class. So go ahead, if you don't have a phone, partner up with someone who does. Now, if y'all can't focus while you're on your phone, I'll be forced to make you use a paper handout, and I know y'all don't want that, so make sure you pay attention and stay focused on your assignment, okay? Alright, so what I want you to do is with your partner and on your mobile device, I want you to look up the state of Texas population growth over the past 100 years. Or let's say 50 years, okay? Last 50 years, I want you to look up population growth. So go ahead, I'll give you a second. Go ahead and look that up for me. Alright, has everybody found a site with population growth? Very good. Okay, what I want y'all to do is just like we plotted the points that were up here, okay? I want you to figure out a way that you can plot the population growth in the state of Texas for the past 50 years. So from 1966 to 2016, I want you to plot a point every 5 years. So that should be how many points? Yeah, it should be 10 plotted points I want on your graph, alright? So go ahead, I want you to work with your partner, plot those, figure out a way to plot them. Okay, there's a couple different ways you can do it. Okay, so go ahead and work with your partner and figure that out for me. Alright, how are y'all doing? Y'all got that solved out? Plotted down? Alright, for time's sake, I'm just going to go ahead and plot every 10 years. So I'm just going to do 5 plotted points, okay? So, let's go ahead. What did you get for your 1966 population? At first, okay, we have our graph here, and these are going to be in millions. So I'll go ahead and write millions over here on the side, and then years over here. So we have our graph. The other way you could have done it is you could have put years up here and the amount of people down here. But for this assignment and just to be able to see our data more easily, I'm going to do it this way. Okay? Either way is fine, and you'll end up getting the same answer. But this just looks better, and for me is easier. But like I said, there's always more than one way to do your lesson or to do your math assignment. Alright, so what did you get for your 1966 population for Texas? Alright, you got 10,492,000. Alright, so we have 1966 right here. Alright, and we got 10,492,000. So we got 11, 12, 13, 14, so it's going to be in between the 10 and 11, so I'm just going to stick it right there. Alright, what about this group? What did you get for 1976? Alright, you got 12.9 million. That's going to be close to the 13 up here. Very good. Alright, Alright, what about 1986? What'd you get? 16.6 million. Alright. That's gonna be right about here. Alright. 96. 19 million. Alright, so you can see that our graph is already increasing and it looks pretty steady, right? Yeah. Okay. 06. 23.5. Very good. Put that about there. And 2016. 27.5. Alright, so you can see we got a pretty steady increase. Now, how are we going to find the slope of this line? As you can see, it kind of, let's see, there's a straight line right about here. You can see this point is a little bit off the grid. So is this one. But for the most part, they stay around each other, right? So in this case, we can draw a line of best fit. Okay? But for this example right now, I'm going to pick 2 points for us to find the slope on. And for these data points that I found just out of every 10 years, I found that this 1986 to the 2006, this line right here makes a pretty straight line that I think fits our data pretty well. So what I want you to do is, using the equation we used previously with the warm-up, I want you to find the slope of this line right here. And that will be actually the slope for the entire population growth that we'll use here in a little bit. Okay, so go ahead and work on that. Alright, so what do we find here? Well, we know that we need the y2 minus the y1 over the x2 minus x1. But what is our y2, y1, x2, x1 going to be? What do you think? Very good. These are just plotted points. Nothing different than what we did before, right? So, we have our years here, and we have our millions here. And the millions are on the y-axis, and the years are going to be on the x-axis. Okay? So, we still have x and y coordinates. We just have to figure out what they're going to be, right? So, this is, we said we go from left to right, correct? So, this is going to be number 1. It's going to be number 2. So, what is our y2 in millions? 2006, what did we have for our millions? Well, in 2006, we had precisely, let's go precise here. We had 23 million. Go ahead and be writing this down. 507,783 people. Okay, sounds about right. Alright. So what about our Y1? What did we get back in 1986? Alright, what did you get? That's right. We had 16,561,113. Very good. Alright, so what do we get then when we subtract them? Oh, we need to find our x2's, right? Alright, so we had 2006. So I'm just going to write, well, I'll go ahead and write 2006. And we had 1986. Right? So, what do we get when we do this? Well, it's going to be, about 7,000, because we have the 23 million, we have the 16 million, and we both have 500,000. So let's go ahead and write the 7 million. And I'll let you do it in a calculator in a second, but I just want to go ahead and write it down to make sure we know where we're at. Okay? Now 2006 and 1986, we have 20 years, correct? Yeah. Alright, so I want someone to go ahead and work this out on a calculator and use the exact number here. Don't use the 7 million. All right, go ahead and use the exact number. Tell me what you get. What did you get back there? Yeah, so we have 347,334. So what is this number exactly? We found this number, we did this whole equation, but what did I find? Yeah, I found the slope. Okay, so let's go ahead and write this in standard form. So I'll just use this y right here. So y equals 347,334 x. Yes, very good. Now, what is my y-intercept? Anybody tell me? Yeah, we already have it right here. 66 is on my y-axis. Okay, so all I have to do is find out what my population was in 1966, and that's my y-intercept. So our y-axis is 10,492,000. Now, real quick, because we're running out of time here, but using this equation, and hopefully y'all have all found it, using this equation, I want you to find what population will be in 2066. So that'll be 100 years from 1966. I want you to figure out that for yourselves. Go ahead and work on that for a minute. Alright, so who can tell me what I need to do to start this equation? And remember, this is our x-axis, this is our y-axis. So what am I going to plug in for x here? I need a plus sign in here. Alright, what am I going to plug in for my x? Very good. I'm going to plug in a 100. So I'm going to get 347,334 times 100. All I have to do is add a couple zeros, right? So that's going to be 34,733,400. And yeah, and then all I have to do is add this 10 million to it. It's 10,492,000. And that's going to give me roughly, yeah, about 45 million. Let's stick to that right here. 45 million people. Now let's look at our graph real quick. Alright, so we have, it's going to be 2066. And according to my line, it's going to be about right here, right? So let's move this over here. And if we have a couple, about 3 or 4 inches per thing, we have 30, 35, 40, 45. It's going to be about right up here, correct? Yeah. So according to our equation right here, and according to our answer, and according to our graph, that all seems to work out, right? Now, I could have used this for years and years worth of data. And if you have an actual population growth, most of the time it's going to be more of what's called a parabola. So, in reality, this is probably going to spike a little bit more and going to be greater than 45 million. But for us today, that's a pretty good estimate and pretty accurate as well. So now, before you leave, alright, and I know the bell's about to ring, but before you leave, I want you to grab a sheet of paper, and for your exit ticket, I want you to write different ways that we can use proportions and that we can use graphs and data such as this in real life. Just other examples you can think of that you can use data and graphing and proportions in your everyday life, whether you use it or just ways, just fun ways. Like I said earlier, you can do fitness tests, you can do sports statistics. So come up with your own example and go ahead and turn that in on your way out, and y'all have a great day.